So I'll give a brief introduction to Pandas. Pandas is a Python package providing fast, flexible, and expressive data structures designed to make working with relational or labeled data both easy and intuitive. So Pandas is basically a scientific package which provides working with data easier as compared to other platforms that are available in the market. Pandas is well suited for many different kinds of data. For example, tabular data with heterogeneously typed columns as in SQL table or Excel spreadsheet, ordered and unordered, not necessarily fixed frequency time series data, arbitrary matrix data, homogeneously typed or heterogeneous with row and column labels, any other form of observational statistical data sets. The data actually need not be labeled at all to be placed into a pandas data structure. So it means that pandas can deal with a lot of variety of data types. Pandas aims to be the fundamental high-level building block for doing practical real-world data analysis in Python. Additionally, it has a broader goal of becoming the most powerful and flexible open-source data analysis or manipulation tool available in any language. It is already well on its way towards this goal. The two primary data structures of Pandas are series, that is one-dimensional, and data frame, that is two-dimensional, and they handle the vast majority of typical use cases in finance, statistics, social science, and many areas of engineering. For R users, data frame in Pandas provides everything that R's data frame provides and much more. Pandas is built on top of NumPy and is intended to integrate well within a scientific computing environment with many other third-party library support. What are the advantages of Pandas? Easy handling of missing data, which is represented as NaN or not a number, in floating point as well as non-floating point data. Size mutability, which means columns can be inserted and deleted from data frame and higher dimensional objects. Automatic and explicit data alignment, which implies that objects can be explicitly aligned to a set of labels, or the user can simply ignore the labels and let series, data frame, etc. automatically align the data for you in computations. This means that objects can be explicitly aligned to a set of labels which are columns, or the user can simply ignore the columns and let series and other data structures automatically align the data in columns for you in computations. Next is powerful flexible group by functionality to perform split, apply, combine operations on data sets for both aggregating and transforming data. So this implies that the group by operations that I'll discuss in the coming slides will have the powerful split, apply, combine operations that can be done on data sets for both aggregating and transforming data. Next is make it easy to convert ragged or differently indexed data in other Python and NumPy data structures into data frame objects. So if we have a ragged array or differently indexed data like ragged arrays or something in other data structures, then this data frame object in pandas module will handle it easily. So next we'll see pandas series. Series is a one-dimensional labeled array capable of holding data of any type, integer, string, float, or other Python objects. That is. So we'll see with the help of an example here. First we import the pandas module in the first line and give the alias as pd. Next we import the numpy module and give alias as np. Next we take a data numpy array and make a series out of that data variable with the help of the series function of the pandas module and assign it to s variable, and next we print s. So it will print the output as shown here. Here this is the label of the series and this is the data that is from the data variable. Next we see second example of pandas. In this we create the pandas series using 1 2 3 4 5 data, and the given index is ABCDE characters. So this will become the index or label, and this is the data against that index. If you want to print the element at ath index, we'll type as print s in bracket quotation a. So it will print the data as 1. Now we'll see a pandas data frame. A data frame is a two-dimensional data structure. That is, data is aligned in a tabular fashion in rows and columns. First we create a data frame. So data is a dictionary that contains first key as name, that has this list here of names. Next key is year, that has list of years against those names, and reports key that has some data in a list. Next, we take the df variable to be a pandas data frame. We create it with the help of the data frame function as shown here, and we pass the parameter as data to it, first parameter. So that will be the data for the data frame, and the index for the data frame is this one, this list of string. So as you can see, these are 6 elements against the each of the 6 rows of each key. So these are the index, and this is the data here. And as you can see, the keys have become column names, and corresponding values are become data. Next, we see how we load a CSV into pandas data frame. So the syntax is read CSV with the part to CSV with file name and extension specified as the first parameter, and the second parameter can be an optional parameter with header is equal to none. If the second parameter is set to true, then there are no headers for the CSV file data when imported. Next, we see how to export our data frame to CSV file. So syntax is the data frame variable name dot to underscore CSV function, and then the complete part to CSV file with name and extension specified. This will save the data frame mentioned here in a CSV file to the path specified here. Next, we see how to load a JSON file into pandas. The format is df is equal to pd, or the alias for pandas module, then dot, then read underscore JSON. This is the function that reads a JSON file and parses it and stores it to the df function variable, and the parameter will be the part to JSON file with file name and extension specified. Next, we see statistical functions in pandas with data frame. So there are many statistical functions that can be applied to various columns of a data frame, and examples include these shown here. For example, the describe function will describe the format of a column of a data frame. The sum function will take the sum of all the elements of that column, and other statistical functions have their specific functionalities. Next, we see how we drop rows and columns in a data frame. Suppose we have imported pandas module as PD, and we have this data variable as shown here, and we create a data frame df out of that data with the index as mentioned. Next, we drop a row from this data frame. For that, we type df.drop cohes. So it will drop this index or row, corresponding row for against cohes index from this data frame. And if you want to drop a column, we define x is equal to 1, which denotes that we are referring to a column and not a row. So df dot drop reports x is equal to 1. That means we are referring to this reports column, and we have to specify that x is equal to 1. That means we are referring to a column, not a row. Next we see join and merge in pandas data frames. The join syntax is the new data frame is equal to pd.concat, and within bracket parameters are is a single list containing two elements, that is the first data frame and the second data frame. So this will join the two data frames along rows. And if we want to join against columns, we can mention as x is equal to 1. So it will join the two data frames along columns. If we want to merge two data frames, we can type pd.merge and the two data frame names and on the column name. It will merge these two data frames on this column name. Next, we see how we find unique values in pandas data frames. There are two ways to do it, and the syntax is shown here. First way is to convert the column required to be a unique set. So we take the data frames column using df dot column name. That will give us the values in this particular column. Convert it to a set using the set data type conversion function. And next we convert it to a list, so that will give a list of unique values. Or we can use the unique function of df or pandas module. So this is here data frame variable, and in brackets the trucks is the column name. That will give all values in the trucks column in the df variable, and we use the unique function here. It will give us unique values in this column, and next you convert it to a list, so it will be a list of unique values. Next we see how we delete duplicates in pandas. So syntax is shown here. First, to identify which observations are duplicated, we type df.duplicated. It will print the rows that are duplicates. And to delete duplicate observations or rows, we type df.drop duplicates. So in this, we can also pass a parameter as first, last, or false. If first is specified, first duplicate is kept. That means uh, a value that is duplicated that is kept, and its first duplicate is also kept, but other values are deleted. Other rows or observations that are duplicates to that value are deleted. And if last is specified, the last duplicate is kept in a similar way. And if false is specified, all duplicates are removed. So this is the format finally: df.drop duplicates column name and keep is equal to, for example, first. Next we see how we deal with missing values in pandas data frame. To drop missing observations, we type df new is equal to df.drop na. This will remove all na values rows from df, and drop rows where all cells in that row is na. That means all the cells should be not applicable in that row, then only we want to delete that. Implies that we write it as df.drop na how is equal to all. Next, to create a new column with all na values in all rows in that column in the data frame, that means we create a new column with all not number values or na values. We type df new location, or that column name is equal to np.nan. It will create a new column location with all values as nan. Next, in a similar way, if you want to drop columns, if they contain only missing values, we can type df new is equal to df.drop na and specify axis is equal to 1 and how is equal to all. Similarly, if we want to fill in missing data with zeros, we will type df.fillNA 0. That will fill all the missing data with zeros. We use the fillNA function here as mentioned. Next, if in place is mentioned and it is true, it implies that changes are saved right away to the data frame. That means the data frame is saved with the changes. So df.fillNA 0 will fill all the missing data with zeros, and in place is equal to 2 will save the data frame.